Hello everybody, my name is Riccardo Bancone, and in this video I'm going to show you a new node that has been added to the latest daily build of Blender, and this node is called Principled Volume. Of course, this is supposed to be used to create volume effects on your models. As far as I understand, this node is not supposed to do anything new at all. I mean that this does nothing that you cannot do with the standard volume nodes that you can find under the shader section here, like the volume absorption and the volume scatter. But the advantage of this shader node, is that it is pretty straightforward. It's ready to use. You just add this node, and you can find it, of course, under the shader section if you press Shift A. And it's called, of course, Principled Volume. You create this node and connect it to the volume socket of the material output, and you're ready to go. Let me show you just a moment my light setup. Pretty simple, just one area light. And let's switch to the rendered view. As you can see, we say almost nothing because the density is too low. If we increase the density, we start seeing our model. Okay, the density parameter defines how dense the material, the interior of the material is. For example, this is a solid model, but if we use a volume shader on the smoke simulation, for example, the density parameter defines how thick the smoke is. So the higher the density, the thicker the smoke or the inside of the material we are using. The first color parameter is the scattering color. So it is the color of the light that gets scattered inside the volume of the model. So right now it is a gray color, but if I change it to, for example, a red color, you can see that the model starts being, of course, red. So this is the scattered light component of the shader. You can change it to achieve different effects. And of course we can increase the density to better show what's going on. So if I set the density to a very high value like 1000, the model starts being almost solid shaded. Look, we can see every little detail of the model. And this scatter color, of course, is the color of the light reflected. Well, not actually reflected, because it travels through the model, not only on the surface, but it travels through the model, inside the volume of the model. And that color is what the inside of the model looks like when the light gets scattered around and reaches the camera. Okay, now as you can see, there is another color here, which is absorption color, and it's similar to the to this color, but this is not about the light scattered by the volume, but it's about the light being absorbed by the volume. So let's make this scatter color black to see what's going on if we change this color. Okay, now we have a density of 50, and by the way, this density affects both the scattering color and the absorption color. So if I turn these up and let's give it a blue color, for example, the absorption color is actually about the light, as far as I understand, is about the light not being absorbed by the model. Let's bring up the density to better show what's going on. If the density is high, a lot of light gets captured by the volume of the model, especially in the thicker parts, as you can see, and therefore they look darker because the light is trapped inside the model, while the thinner parts let the light go out from the model after it's been like filtered by the material, let's say like this. And this color is about the light that can go out from the model after it's been transmitted, let's say like this, from the material, by the material. So you can use this absorption color to create, for example, colored glass effects. Let me show you an example. Let's create a glass shader. Let's connect it to the surface. Maybe the density is a little bit too much. Let's bring it back to 50. Let's change the color to a more glassy color. Maybe darker color, like this. It's very nice to use this volume absorption for this purpose. As you can see, the thinner parts are more are clear. There's almost no color, but the thick parts, for example the cheeks of the model, are more colored. They are more saturated. Let's play with the density a little bit more. Nice. So this is useful to create this kind of effect. Okay, now we can disconnect this because we don't need it anymore. Let's see what this emission strength does. First of all, I'm going to turn off my light here, so I have no light in the scene. Everything is completely dark. If I use this parameter, let's get up, the volume starts emitting light, and the light looks like a little bit colored because of the absorption color. So this definitely affects the look, because the emission is white, but it's being filtered by the volume itself. In fact, if I increase the density, more light gets absorbed, so the emission looks somehow weaker. So let's bring it back to a density of 1, and as you can see, the absorption color is green, but since the density is lower, this affects the density, the color of the light, let's say like this, in a minor amount. I don't know how to say that. And okay, let's make it white to white, no saturation. So the emission color is white, but we can of course change the emission color, and we can play with the settings to achieve different effects. And so we can make the material emissive and tweak the color, or we can just set it to 0, back to white, and back to white, and use the black body intensity instead. Let's crank it up. The black body is another way of creating emissive material, but in this case we are not directly using an RGB color, but instead we are using a temperature in Kelvin to create a colored light. So the higher the temperature, the more the color is biased towards the blue spectrum, I guess. I'm not sure what's going on here. So the light is now a little bit colder. So we have the black body intensity that modulates the intensity of the emission, and the temperature as well, that I think it's actually affects both the color and the intensity. So the higher the temperature, I'm not sure, but it seems like this, the higher the temperature, the higher the emission intensity as well. So because in fact if I type 1000, the temperature is pretty low and I have almost no emission visible. But if I crank it up, I can see that the emission increases and the color changes as well. So you should see how the black body now node works to better understand how this thing works. Anyway, you can tweak the emission color both directly with RGB value, with an RGB value, and with the black body. And you have also a tint here, which of course somehow lets you tweak the color of the black body emission. Okay, now I'm going to show you how these attributes, density and temperature, for example, affect the shader. But I'm going to use another object here, which is a smoke simulation. Pretty simple. I have an emitter object, which is my icosphere here. It's a little bit deformed by a displacement modifier. It is animated. It just moves around into the domain and emits fire and smoke. As you can see in the physics parameters of the emitter, I have fire plus smoke. Ignore the green color for the moment because it's not going to affect the look, because I changed it after I baked the simulation. Let's see the settings for the domain. Of course, I applied my principled volume shader to the domain object, and I used a division of 250. I used 250 divisions for the smoke domain, and I didn't use any smoke high resolution setting because it would slow down my viewport. So for the sake of this tutorial, I just used a pretty high amount of divisions of the domain. So let's render the smoke and let's see how it looks. There is no light, I have to turn it on. Okay, this is the smoke. I used, as you can see, this color for the scattering color and this color for the absorption, and also I tweaked the anisotropy here, which is about the direction of the light being scattered through the volume. This parameter is a parameter that has a max value of 1 and a minimum value of -1, and if it's positive, so towards the 1, that means that the light, let's hide the background, that means that the light gets scattered more more in the same direction of which the light hits the volume. So in this case, for example, an anisotropy of 0.1, let's actually use a very high value and let's render it. I have to what's going on here. Okay, as you can see, let's just add some ambient light here, some word light. With a very high value of anisotropy, a very high positive value, the smoke all looks very dark, at least from this point of view. Pay attention that the light is up here, so the light source, I mean, and the light is traveling in this direction. This value means that the lights get scattered mostly in this direction, like this. In fact, if I go here with my point of view, I can see that the smoke now has a nice bright outline. Let's call it like this. Let's tweak the volume, the intensity to see what's going on. Look, the light is scattered in the same direction of the rays that hit the volume. In fact, if I stay here, the volume looks like it's completely black, but if I go here, I can see the light passing through the smoke. If I go here, it's still black. But if I'm here, just behind the light, and I'm looking just at the smoke, let's go closer. I'm looking at the smoke roughly from the point of view of the light, and I lower the anisotropy and I go close to -1. I can see that now the light, first of all, the smoke appears almost white if I see it from the light point of view, but if I move, it gets dark. Why? Because the lights get somehow reflected back to the light, because this value, the negative value, means that the light gets scattered mostly but toward the light. So to see the light bouncing on the smoke, I have to be here, and the values in between make the light scatter on just around the directions. If I put a value of 0, if I type a value of 0, the light gets scattered around in equal, let's say, with an equal probability in every direction. So if I want the light to be scattered more, let's say, I want the light to go through the smoke and get scattered back here, I just use a little bit positive value, let's say 0.2. Now let's see what these attributes are about. First of all, the density attribute is used when you use, like in this case, when you use, for example, a smoke simulation, which has an attribute called density. And the density attribute is about the domain and tells where the smoke is has a higher density, for example here, and where it has a zero density, for example here, and so on. So the density attribute of the smoke simply tells where the smoke is in the domain and how much dense it is. So in fact, if I delete this one and I render this, I simply have the whole domain with a constant density of, in this case, 37. I think it was 75. To use the smoke, if I want the smoke to be rendered correctly, I have to type the exact name of the attribute here, which is density, and I have my smoke back here, maybe 65. So this is let's say, the base density of the smoke in the domain space, multiplied by this constant density. So basically I can tweak the whole smoke density using this slider. So I can have a smoke like this, or I can have a thicker smoke by increasing the density multiplier, because this number that we used on the Yoshi model is the same, but it is multiplied by the density attribute of the smoke. In the case of Yoshi, for example, I just have a constant density for all my model, for the whole model, I mean. But with the smoke, the density of the domain is modulated by this attribute in the 3D space of the domain. Okay, just like the density attributes defines where the smoke is, the temperature attribute defines where the flame is into the domain. You can also use, I believe, let's try it. I think you can also use the flame attribute, which is another attribute of the smoke simulation. Let's try it. Yes, as you can see, it works, but it's definitely weaker. So by default, the temperature is the attributes that drives where the flame is, and by where the flame is, I mean the emission intensity of the domain. So in this case, I don't have a constant emission. So if I remove the attribute name from this field, the whole domain has an emission value, which in this case I defined using the black body intensity. The color is driven by the temperature. I can change the color of the emission by increasing the temperature, and I multiplied the intensity by the black body intensity. Of course, without any attribute here, the whole domain is rendered as a big emissive cube. So I have to use the temperature attribute to tell Blender and Cycles to just render the fire when the temperature is high. So specifically here. Let's see if I can better show you. This is, I changed the frame, so I went to frame 7. I can see that here there is the flame driven, let's say like this, by the temperature that tells Cycles where and how hot the flame is. The color of the flame is defined by the temperature, and the intensity is defined by the black body intensity. Of course, I can use, I can set it to 0, for example. I have no fire at all, but I can use this one. Interesting. The emission strength seems to be not driven by the temperature attribute. Let's see. Let's say if I, yes, if I want to use this thing, I think I have to use this attribute manually. And by the way, here I tried to recreate this node behavior, and I succeeded for the part of the smoke, but I couldn't find a way to reverse engineer the emission part. I tried to do something similar, but I could not obtain the exact result. So let's go back to the old settings. Let me show you the shader tree that I created to emulate this behavior, the behavior of the principled volume. As you can see, the smoke is roughly this. No, actually, I think it's the same, but the flame is different, and I actually wasn't able to replicate that exactly. I just used some tricks with the hue saturation to make it more or less similar to the principled shader. Anyway, you can use this setup to create a similar effect, but with this node, it's definitely quicker and simpler and more intuitive. Since this node has been just added, it probably will change. So probably, I don't know, actually, it's probably being it probably will be changed, but I'm not sure about that actually. Let me show you just how the color attribute influences the color of the smoke. And to do this, I have to free the bake, because otherwise the color of the emitter, which is this one, if I select the emitter, I can choose the smoke color of the emitter. But as you can see, this is green, but if I type the attribute that I want to use to drive the color, it shouldn't affect the simulation. Let's render. As you can see, even if I set it to a white color, oh, sorry, I'm not using the right one. It is white, but color attribute is not affecting the smoke. But if I just free the bake and redo the simulation. I should probably be able to see the color. So let's change it and let's simulate again. Okay, now you can see that in the viewport the color of the smoke is green. Now if I render it, the green color is somehow being mixed with this color. So these colors still affect the smoke. So if I use an absorption color, let's bring it down a little bit so better see. If I use, for example, an absorption color, a red absorption color, and a red scattering color, and then I use then I change the smoke color into the emitter settings, this will affect, let's change it to blue. Okay, let's go back to the menu to see if it's working. Maybe the color is too saturated to see the effect. It seems that it doesn't update instantly. I think I have to run the simulation again to see the effect. Here, as you can see, the smoke starts being blue. Okay, the smoke is blue. I render it. It's blue. If I change the, for example, the scattering color, it somehow mixes with the blue. So the color of the smoke now is affected both by the scattering color, the absorption color, and the smoke emitter color itself. Well, that's it. This is all I could find out so far after playing a whole day with this nice principled volume node, and I hope it helps. See you next time.